och välkomna. Under cirka 10 minuter ska ni få följa med mig, Marie och min kollega Per. Ni kommer få se aldrig tidigare visade utrymmen och ni kommer få höra historier som ni inte har hört förut och inte visste fanns. Häng med!
Grimeton radiostation stod färdig 1924 och var då en del av ett globalt nätverk av radiostationer av samma slag. Långvågssändarna här i Grimeton de användes för att sända trådlösa meddelanden, så kallade telegram, från Sverige till USA och närmare bestämt New York. Att vi kallar det långvågssändare, ja, det är för att de radiovågor de alstrar är väldigt långa, närmare 18 kilometer. Vi ska nu gå in och beskåda det här stora maskineriet som stationen byggdes för. Det ni ser här inne i sändarsalen, det är de stora maskiner som användes för att sända meddelanden med nära nog ljusets hastighet till New York. Grimeton användes bara för att sända information, inte för att ta emot, utan det gjorde man uppe i Kungsbacka. Grimeton var den optimala platsen för en radiostation av det här slaget, för med sin kustnära placering så kunde man sända ut sina radiosignaler utan risk för att de skulle försvagas av eventuella landmassor på vägen över Atlanten. Ett telegram kostade nästan 7 kronor på 1920-talet, vilket var en stor kostnad då och motsvarade ungefär en dagslön för en vanlig arbetare. Behovet av att kommunicera mellan kontinenterna hade länge funnits och dittills tillgodosetts med telegrafkablar som var nedlagda på havets botten, bland annat Atlantkabeln som länkade samman Europa och Amerika. Under första världskriget blev kablarna mål för krigshandlingar, något som resulterade i en strävan efter säkrare och effektivare kommunikationsvägar. Systemen för trådlös kommunikation växte fram.
Innan vi kan starta sändaren behöver vi slå till dessa knivar som finns i det så kallade transformatorrummet för att få kontakt med transformatorhuset cirka 100 meter bort härifrån. Ursprungligen fick sändaren sin elektricitet från vattenkraftverket Ingredsfors lite utanför Falkenberg. Så, nu är det bara att starta sändaren. Eller bara förresten, förutsatt att inga problem uppstår. Sändaren gör körklar på cirka 15 minuter och till detta behövs 2 sändarvakter. Startar du sändaren, tack! När sändaren var igång fick man ropa till varandra för att kunna kommunicera. Den vanligaste arbetsskadan när det begav sig var just hörselskador. Sändarvakterna tilläts inte att använda något som helst hörselskydd, då man var tvungen att urskilja missljud i maskineriet. Men idag använder vi hörselskydd.
Radiostationen i Grimeton har ett omfattande stationsarkiv som sträcker sig ända tillbaka till 1920-talet. Bland materialet finns bland annat ritningar över det stora långvågssystemet som placerades här och som hade utvecklats av uppfinnaren och ingenjören Alexanderson. Alexanderson var svensk-amerikan och tilldelades under sina verksamma år 344 patent, bland annat det för långvågssändaren som användes i Grimeton. Det som var speciellt med denna sändare var att den var högeffektiv och kunde sända på en särskild frekvens, vilket också gjorde att man kunde tilldela stationen sin egen sändarkanal och en mottagare visste därigenom med säkerhet vem det var som sände. Hans uppfinning gjorde det möjligt att ännu snabbare och ännu säkrare sända trådlösa meddelanden över långa avstånd, något som vi idag tar för givet. Alexanderson är med andra ord ett namn att lägga på minnet och han i hög grad har bidragit till hur vi kommunicerar idag.
Vem var det som arbetade på radiostationen? Under bygget samlades många lokalbor som behövde en extra inkomst och arbetet leddes av ingenjör Norén från Telegrafstyrelsen. Han hade fått till sig av den amerikanska leverantören att bygget av en stor radiostation minsann inte är någon barnlek. Därför var det bra att Norén hade erfarenheter av liknande byggen sedan tidigare. Han var anställd av Telegrafstyrelsen i Stockholm och reste ner till Grimeton för att förhandla med bönderna kring införskaffandet av marken. Den ena efter den andra ville vara säker på att varken ta för lågt eller för högt pris gentemot sin granne. Förhandlingar som krävde mycket tålamod och mycket konjak till kaffet. Bygget påbörjades 1922 och stod alltså färdigt endast 2 år efter, trots en omfattande järnstrejk med tillhörande förseningar.
På stationen fanns en mängd olika yrkesgrupper. Ingenjörer och maskinvakter, mastmålare och kontorister för att nämna några. Maskinvakterna de bemannade stationen i 3 skift, det vill säga stationen var i bruk dygnet runt. Under nattpasset ingick att med denna behändiga dammsugare se över golvytorna och snygga till inför den kommande arbetsdagen. För att se till att detta arbete gjordes ordentligt brukade en av ingenjörerna gömma apelsinkärnor i skrymslen och vrår. Var dessa borta när han kom dagen efter så visste han att arbetarna hade gjort ett ordentligt jobb. Dock lärde sig dessa ganska snabbt var han brukade gömma kärnorna och kunde därigenom bespara sig en hel del besvär. Förutom radiostationen och de 6 antenntornen så byggde man också ett antal arbetarbostäder. Detta kommer att bli den så kallade radiobyn där vi befinner oss nu, ungefär 400 meter från själva radiostationen.
I radiobyn bosatte sig bland annat stationschefen och ingenjörerna. På kontoret där jobbade fru Bengtsson med all administration och varje fredag radade arbetarna upp sig på led med mössan i hand för att ta emot sin lön. Fru Bengtsson var den enda kvinnliga anställda på radiostationen under många år.
Till skillnad från många liknande anläggningar så kom Grimeton radiostation att bevaras. Och det berodde på att man här dels placerade in nya sändare i stationsbyggnaden och ut på området uppförde man nya antenner. Och än idag är Grimeton radiostation en aktiv anläggning för radiokommunikation. Dels har vi radioamatörer här på området som kommunicerar med likasinnade runt om i världen. Och vissa av antennerna här ute de hyrs ut för att kunna tillhandahålla kommunikation inom bland annat flyg och sjöfart. Genom detta så fyller vi en viktig samhällsfunktion. Detta genererar också intäkter som kan gå till bevarandet av det gamla maskineriet. Och på så sätt bidrar till att levandegöra kulturarvet.
Nu vet du varför just den här platsen är så speciell och ett världsarv sedan 2004. Det är UNESCO, FNs organ för vetenskap, utbildning och kultur, som utser världsarven på världsarvslistan. Den här platsen är helt unik och finns ingen annanstans i världen. Välkommen att besöka oss.
Byta batteri. Det ska ta ut. Ray? Working? Yep, perfect. Here. All right. We'll take it from here. My name is Fredrik Wiklund, and I am the chairman of the Alexander Association. Alexander Association was formed in 1996, and we are volunteers to work with this fantastic from det är inte bra. Working here. 1, 2. One, 2, 3, 4. No. Cannot be heard. Yeah. Ja, det kanske är bäst. Det går ut i sändningen. Alla som har gula lurar här, eller grå lurar här, ska byta till gula. Nej, vi vill ha ut ljudet här. Jag fortsätter att köra gärna. Yes. Yep. Och du fortsätter att prata. Vi kan be alla växla till gula lurar. Så du kan be alla... Nej, vi har ett tekniskt problem. Ja. Vi hörs ut på i sändningen. Ja. I think we will continue. Nej, vi fortsätter. Janne löser det. We will continue. Nej. They are working on getting the sound to the grey headphones, so that will come. All right, I'm sorry for that technical interference. We will now continue to give you all a little bit more in-depth technical description of this fantastic machine. So I will walk together with Oliver Leiner, our photographer, and show you the machine. So we start here at the heart of the Alexanderson alternator. This is the place where the radio wave is being created. Inside here is a metal disc with a diameter of 1.6 meters, and it will rotate at a speed of a little bit over 35 turns per second. In the periphery of this metal disc are 488 cut-out slots, and they are filled with a non-magnetic material, brass. Around these rotating discs are 64 windings, and each winding there is current running, and when metal is passing a winding, you have a variation in the magnetic flux. So with the 488 slots rotating 35.25 seconds, 35.25 turns per second, we will get a frequency of the radio wave inside here of 17,200 hertz, 17.2 kilohertz. That's our transmitting frequency. The Alexanderson alternator is connected to a gearbox, and the gearbox is connected to the main motor. The main motor is a 500 volt, two-phase asynchronous motor. So the speed of the motor is directly related to the frequency, and here we have one of the great challenges with this transmitter, to maintain an even speed at any point in time. And we do that by several means. First of all, the current going to this motor is fed through a series of transductors. Transductors are devices invented by Ernst Alexanderson, who invented the Alexanderson alternator, to allow a relatively small DC current to control a much larger AC current. And then the rotor, usually on an asynchronous motor, the rotor is short-circuited. On this motor we have the rotor wound three-phase, and each phase has its own slip ring, as you can see here. And they are led to a variable liquid resistor, so that we can more or less steplessly control the resistance in the rotor, and thereby control the amount of power going to the motor. So let's go down and see where the power gets in. So this is where the power gets into the station. We have a 50,000 volt supply externally, 200 meters away from here, to a transformer house. And inside that transformer house, we have a transformer converting the 50,000 volts to 2,300 volt two-phase. So it's a very special transformer. And you saw the knife switches here that is supplying 2,300 volts. Now you're seeing the transductors, one for each phase. So the supply to the main motor is going through these 4 transductors. And then finally we have a set of Scott-coupled transformers that converts the 2-phase back to 3-phase again, strangely enough, because some of the auxiliary machinery would require 3-phase. And here behind me we have some of the auxiliary machinery. Here we have rectifiers to produce 500 volt DC. Here we have rectifiers to supply 125 to 150 volt DC. And you can see that we have a double set of each one. So one is operating while the other one is backup. Here we have 2 water pumps, pump number 1 and pump number 2. They are used to create a circulation in the water cooling system. The water cooling system is cooling the alternator, the liquid resistors, and the high frequency amplifier, which we will look at later. Today we will run pump number 2, which is over here. Here are the 2 liquid resistors that we use to control the power supplied to the motor. Each phase from the rotor is led into several pipes and plates mounted inside this vessel. Inside the vessel is an adjustable gate that allows us to control the level of water, and by that how many of the tubes, metal tubes, that will be in contact with the water. And the more tubes that are in contact with the water, the lower resistance we will get, and the more power we will get to the motor. When we start the motor, the level is at the bottom to allow for highest possible resistance. The control resistor will only be connected when the telegraph key is pressed down, because when the telegraph key will be pressed down, we charge the motor and we need more power. So the control resistor is then connected in parallel with the start resistor. And 2 resistors connected in parallel will create a totally lower resistance, and by then add a little bit more power to the motor while the key is pushed down. Controlling the motor creates very high powers through our contactors, and thereby we need to have one cooling fan blowing compressed air on all the main contactors to prevent them from burning. We have 2 fans, 1 and 2. We will be using fan number 2 today. So one is always in backup. And now we are entering the relay corridor. Here is where the signal from the telegraph key is entering the transmitter. Originally, back in 1924, messages were not telegraphed from this building. Instead, they were remotely controlling this transmitter from the radio central in Gothenburg over the telephone net. So the telephone wire from Gothenburg radio was connected in here. That signal is then amplified over this or that relay, and then further amplified through these sets of relays. Here we have a set of really large contactors. They are used to either control the 500 volt power supply to the transductors, or connect the control liquid resistor in parallel with the start liquid resistor. And they will be operating in the same speed as the telegraph key to add or reduce power to the motor to maintain an even speed. You can see that there are two wooden bars hanging here in a couple of chains. They are used to prematurely, before we start the main motor, start the circulation in the liquid resistors. We will operate them in a while. Then I will walk down to the magnetic amplifier. So the magnetic amplifier will be connected to the alternator when the alternator is at its optimal speed. At the top, you can see we have two cylindrical shaped devices here. They are amplifiers amplifying the signal from the alternator, or when the key is up, preventing the signal to pass through. At the bottom there are also two transductors, and these two transductors will be operated in the same speed as the key, and when the key is up, the transductors will change the impedance, or you can say the tuning frequency of the antenna. So it's really clever. So to control the power going out to the antenna, we have the amplifiers that will prevent or allow power to go through, and we have the transductors that will tune or detune the antenna, depending on the position of the telegraph key. To be able to tune the antenna optimally to have the same resonance frequency as the Alexanderson alternator, there is an adjustable coil. And this coil can be rotated 180 degrees to increase or decrease impedance. And we can control that over from the control panel. And if we follow the copper tubes leading up into the roof and through the wall, that one of the tubes is the antenna signal, and the other one is a common ground for the antenna and the transmitter. So we are walking back to the control panel. So on the control panel is where we operate the machine. On the left-hand side, we have the high power levers to turn on the main power, the main motor. Auxiliary machinery can be turned on and off here. In the center, we have what is called the automatic speed control system. And over to the right, we have a set of meters that will allow us to monitor what is going on. We also have a set of push buttons and buttons that we can push and pull in order to maneuver the machine and tune it as close to our optimal transmitting frequency, 17,200 Hz, as possible. So that was a short introduction to this fantastic machine. I have spent 10 years here at this radio station, more or less every week, and I still don't have a complete picture of this machine and how it works. So there's a lot to learn here. But we have a lot of very skilled people here who has a great deal of knowledge that they are very happy to share with anyone. So by that, I will we will now start the machine. Today, we are not able to transmit any message out of the antenna, unfortunately. We have some technical issues, and in our ongoing maintenance work, we are missing some of the parts. So we will, however, be able to run the machine in here, but we will not be able to have any message sent out over the air. But considering that the machine is from 1924, it's 98 years old, it's maybe acceptable. All right, so I have Jan-Åke here, who will be helping me to run the machine today. We have done some preparations before. We have checked all the oil. We have made sure that we have a power supply coming in here. So the machine is now actually hooked up to the 2300 volts. So I will ask Jan-Åke to go down to the emergency stop and be ready there in case something happens when I turn on the main switch. Low voltage relay I will start to close, and then I will connect to the main power. And we can hear that there is an alarm bell ringing, and the alarm bell is now telling us that we are lacking cooling water and we are lacking oil pressure. So we need to do something about that. And Jan-Åke will turn off the alarm while we are fixing that. So Jan-Åke and I will walk down to the water pump. And we're going to run pump number 2. And Jan-Åke will start by opening up a water supply and at the same time a bleeder valve at the top of the pump and empty out any air inside this centrifugal pump. And there we go. Jan-Åke will turn off the bleeder valve and it's time to start the pump. So we have a delta star starter. And there the pump is running. And now Jan-Åke will, not that one, that one. Jan-Åke will open up the circulation valve, a quite large ball valve. And I will turn off the water. And we have a gauge here on the wall. So we want to see at least 2 bar pressure is equal to 30 psi. Yeah. Perfect. Now we see that the water pump is running. We are passing by the liquid resistors and checking the water level. In case we need to fill up some water, it's taken from the circulation loop, and that's why the circulation pump must be running before we do that. And now Jan-Åke will use those wooden blocks to start the circulation pump in each one of the liquid resistors. And he is putting on some safety gloves because right next to where he is pushing there is 440 volts, so we don't want anything to happen. So the electrical safety is not up to 1922 or 2022 standard. It's 1924 standard. Okay, so we have water, and Jan-Åke will turn the alarm bell back on again, and we still have an alarm, now indicating that we are lacking oil pressure, and for that we have an auxiliary oil pump that Jan-Åke will start up. And the auxiliary oil pump will provide enough oil power to the alternator when it's starting up. Okay, Jan-Åke, so you can go down to the emergency stop, and we are ready to turn on the main motor. And he is ready. And I close the 0 voltage release, and I turn the main motor. And then if we turn around, we can see that the motor is starting to rotate. I am looking very closely at the amperage meter to the motor, showing 150 amps. So it's almost bottoming out. The power to the motor is 1200 volts. We have a meter for that over here. And the oil pressure inside the alternator is now building up by itself. So at the point we will have an alarm indicating that we can turn off the auxiliary oil pump. We usually get an alarm that we can hear, but not always. But we always get a lamp. So I will watch very closely to see when the lamp is turning on. There we go. So I can turn off the auxiliary oil pump. We are monitoring the amp meter, and we can see now that the power is slowly starting to decrease. We are at 130 amps, and we are slowly going down towards 75. So when we have reached 75 amps to the motor, we will continue to start the rectifiers for 125 to 150 volts and the rectifier for 500 volts. And you can see now that the alternator is gaining speed. Right now it is turning with about 600 RPMs, and we are aiming at 711.3 RPMs. So that's the magical number in Grimeton, 711.3. And the amperage meter is showing 80 amps. So right now the transductors are not supplied with any control power at all, meaning that the transductors are creating a very big resistance. So from the 2300 volt, only 1200 volt goes to the motor. And now Jan-Åke will turn on the 125 to 50 rectifier and the 500 volt rectifier. And then he will connect 500 volt DC to the transductors. And we can immediately hear that the alternator is increasing in speed, and we can see on the gauge that we have now 2300 volts going straight to the main motor. And then Jan-Åke will increase the water level in the start resistor by raising the gate. And then he will close the 250 volts to magnetize the alternator, and now we have a carrier wave inside the alternator. And we have a modern frequency counter showing us the frequency of the alternator. Right now it is 17,045, 60. We are looking to get to 17,200. So Jan-Åke, he can raise the level in the start resistor by just a little, meaning that we will have a little bit more power to the motor, and thereby we increase the frequency. It has a rather slow reaction time, meaning that any activity can take quite a long time until we see the result. We are slowly getting closer to our desired frequency, 17,200. I think Jan-Åke can give it one more push. Yeah, I think we can leave it there. And now Jan-Åke can turn on the cooling fan. I will stay here to make sure that the machine is running okay. And the audience here in the room can now feel that the noise level went up a lot. So if you just lift your ear protection a little bit, you can hear that the noise in here it's quite high. Now we should connect the magnetic amplifier. Hårdare. Yeah. And a motor-operated night switch is now connecting the alternator with the high-frequency amplifier. And then Jan-Åke can try the test key. Yes, and we see that it's responding. And we can turn on the hole punch strip reader. So the hole punch strip reader has a message. The message is V as in Victor, and V in telegraph language means hello. So we are saying V, 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 and then we are saying VE, de, which means from in French. And then we are saying the call sign for this machine, SAQ. So we are saying VVV, the SAQ. And it's a continuous loop like that. I'm going to take you for a short walk. to show you the antenna. And now you can see the cooling pond where the machine gets extra cooling if needed. And then we have the 6 antenna towers stretching 2.3, almost 2.3 kilometers. There's 380 meters between the towers. The radiation of radio waves does not take place from the top network that many people believe. Instead, the radiation is taking place from a vertical wire leading from each tower down to a large coil, a large tuning coil. So that's where we have the radio waves leaving the antenna from. This antenna is basically omnidirectional, meaning that it's radiating equally in all directions. And we have received a lot of questions if this antenna is directed towards New York. The receiving station was placed on Long Island outside New York, but it's actually not facing Long Island at all. You can say that it's 90 degrees from New York, but as it is omnidirectional, it doesn't really matter. And we are getting ready to telegraphing a message in 1 minute. So now we have 1 minute before we will telegram a message.
Den där. Det är den, ja. Japp.
Very good. That was our 2022 telegram. The telegram this year is commemorating some of the major achievements, radio achievements, made 100 years ago. In 1922, the first radio was installed in the White House in Washington, D.C., 100 years ago. And it was also in 1922, BBC, British Broadcasting Corporation, started their commercial broadcasts and news bulletins. But most importantly, in 1922, the political decision was made to build this very radio station by the Swedish government. And 11:45 today, there will be a lecture here talking more about the political decisions and how the radio station was constructed and erected. We have now delivered our message, unfortunately not over the antenna, but we're very happy to see so many people in the audience here today for the first time in several years due to the pandemic restrictions. Last year we were 7 people here in all. So today we are maybe 100, which is fantastic. So thank you very much for coming. We are now ready to turn off this radio transmitter, and we do that by cutting the 500 volt and 250 volt supply, and we can immediately hear that the motor is slowing down. And then I will turn off the main motor by releasing the low voltage release, and by that I turned off the power to the motor. We can also turn off the rectifiers for 500 volts and 425 to 50 volts, and we will lower the water level in the start liquid resistor. The motor takes about 9 minutes to turn off. From that we cut the power, so it takes a long time. It's a huge mass. The Alexanderson alternator disc, 1.6 meter in diameter, weighs about 1,000 kilos. So there's a lot of this now, and it takes time to stop. And then Jan-Åke will turn off the cooling fan. And that reduces the noise level inside the room. And anytime soon we will get an alarm. And what alarm would that be? Well, it would be oil pressure alarm, because the internal oil pump is not any longer delivering enough oil pressure. So I will again turn on the auxiliary oil pump to provide enough oil pressure. And one have to understand that this machine was built in 1922, 1923. There were no ball bearings anywhere in this machine. All bearings are friction bearings. So any bearing here needs lubrication oil. So that's why we have to have a built-in oil pressure pumps. So by that, we would like to thank you everyone who is watching, and thank you all the audience here for attending this transmitter startup. Before we stop, I'd like to talk a little bit about our organization. The Alexander Association is a voluntary organization with 650 members about. Of those 650 members, some 15, maybe 20 persons are very active, coming here every week or every second week to maintain a machine. We would be happy to see new faces here. Anyone is welcome. Anyone can do the job I'm doing here now to run this beautiful machine. It takes a little bit time to learn, but it's possible for everyone. So if you're watching, go to alexander.n.se and apply for membership. And for people who are here in this building, there is a flyer here with a QR code you can scan, and then you can apply for membership. It costs 125 Swedish kronor per year. That's 12 euros. It's very cheap. But then you can also attend some of our courses to how to run and how to operate this fantastic machine. So by that, I would like to say thank you very much for watching, and there will be a new transmission starting at 1:10 local time here, so in a couple of hours. So thank you very much from Grimeton radio station, and bye-bye. And for everyone here in the whole